Right, so question 2. We've now got A part 1, which tells us that part 2 will be closely linked to this. So firstly we've got y equals x e to the 2x, and we've then got two parts of x, two functions of x there, an x part here and an x part here. So we're asked to differentiate that. And what you're going to use here is that y dash equals u dash v plus v dash u, where y equals u and v, while y equals u v. So v is our first point here. So we differentiate that first, that gives us 1, and then we leave the second one alone. And then the second part is we differentiate this, which will give us 2e to the 2x, and then the u we leave alone, which is just x. At that point, e to the 2x plus 2x e to the 2x is what we're looking for as the answer. Part 2, find an equation to the tangent of the curve at the point. So if we've got what the gradient is at any time, we're looking at the point 1 e squared. So that implies that then x equals 1. So dy dx then is equal to e to the 2, if we put 1 in there, plus 2 lots of e to the 2, which gives us 3e to the 2. That's then giving us our gradient. And then we use y minus y1 equals mx minus x1. So it's y minus y1 is our y coordinate here, so that's e squared, equals m, which is 3e squared, x minus our x coordinate, which is 1. They're quite happy with leaving it at that, so that will then give you your full 2 marks. Part B, you're given a quotient being something over something else. So they're asking you to use the quotient rule to prove that dy dx equals that, and you've got to find what k is. The thing I like about this question is that you're given what the answer is to try and prove. Obviously you've got to find k, but it gives you a structure. So v stays, u dash minus and then v dash u all over v squared. That's the formula you need to remember. So let's go through this then. So y dash equals v, so we leave the bottom bit alone. We then differentiate our top part. So differentiating that, the 3 comes to the outside times by the 2. Sine goes to cos, it's 3x. Then it's minus v dash this time, so we're now differentiating this. We're differentiating that will then give us minus 3 sine 3x. And then our u is just 2 sine of 3x. And that's all divided by v squared, so that's 1 plus cos to the 3x all squared. So we're looking at this then, and well, what do we do? Well, first thing to do is start timesing them out and see what we're left with. So we've got 6 cos 3x, 1 times that. Then this times this will give us plus 6 cos squared 3x, times in this by this. Then we've got 2 minuses will make it a positive. So we've got a plus. 3 times 2 is 6, and sine 3x times sine 3x is sine squared 3x. One plus cos 3x squared on the bottom. At that point we then go, right, okay, what can we do now then? Can we put anything together? Well, what you can spot, and if you do spot it, your cos squared and your sine squared, you can write that. If you take the 6 outside, you end up with cos squared 3x plus sine squared 3x. And you should be aware that cos squared x plus sine squared x gives you 1.
So at this point then, we've just set this equal to 1, so I'm just going to write that out again on the next slide, but put in 1 instead of the whole lot. So that leaves us then with 6 cos 3x plus 1, and then that's all divided, sorry, plus 6, plus 1 at all, and then that's all divided by 1 plus cos 3x squared. And then we look at it and go, right, we've just got to make it a 1 plus cos 3x, not 2. So if I take out a 6 again, and again this is just seeing what happens, it actually gives us cos 3x plus 1 here. So if we've got a bracket 1 plus cos 3x all squared, then you can actually get rid of that because it's 1 plus cos 3x, 1 plus cos 3x, so one of those brackets will cancel. So I'll just write it down like this so it makes more sense to you. So when you square a bracket, in effect it's bracket times bracket, so that bracket will go and it'll cancel with that, and that will leave you then with 6 over 1 plus cos 3x, which then implies that k, our integer, is 6.